And if in some mathematic difference to train on compared to and if the homogeneous all that.
So I will today I will present about visual programming, compositional visual reasoning without training. It published CVPR 23 and it's a best paper. So the overview, the problem statement is it's very difficult to scaling a general purpose vision system, vision model to handle complex tasks. And also it's so that difficulty come from the due to the diverse task range, and also they need to have a well curated massive data set for the training. So the benefit for using LLM is that they can decompose a complex task to some simpler tasks, and for each simple task, they can use the vision model that specify training on this task. And also for the LLM, it can show the intermediate step that is show to solve that query. So it's enhanced the interpretability and also for the error analysis. And also they aim to generate the Python program, which is interpretable. And also actually we don't need a neural model to do some simple logical or like some math operation. And it's also easier to communicate with vision and language models. So it comes to visual programming. So it's a neurosymbolic approach. Neural meaning that they use language and vision model that already trained, and the symbolic is so they generate the Python program and also the visual rationale. So the contribution here is like they using LLM to generate the Pythonic program. It's not really Python. You will see here. How can I zoom it in? Can I? No, right? Maybe too small for you, but it's like the program will be like object 0, object 1, image, object, image, and here is the function that it will hold to vision model. So it's something like this. And also the contribution is the visual rationale to enhance the performance and also analyze the errors. And here you can see that like they will evaluate their work in 4 tasks, which is like visual question answering, the reasoning for the image, and also factual knowledge on object tagging, and also the image editing. So for the related work, for the model, the pre-trained for task-specific model, actually they perform really well for the task that it be trained, but it's time and resource intensive for training those kind of model, and also to adding new capability for the existing model is very hard. For the fine-tuning, it's easier. We need to fine-tuning the model on the new task, but usually it's suffering from the forgetting of the old task, and also Another way is like retraining on the existing task and train the new task for that model. For other general purpose vision system, for example, like you may know that like GPP1, 2, Flamingo. So it's very hard for a huge data set for each task. Like they need to homogenizing the data set format and also come up with an idea to train on the task in kind of like similar way. And also they need to train the system for a very large number of tasks. If the number of tasks is not enough, then it just like end purpose task visual system and it's failed to perform in any normal task. And also like they need to balancing the performance across tasks. So the example of this system. So for example, if we have a task like tag this for Charizard tournament champion. So the way that human do it is like, so first you will find the face in the image and then search from internet the keyword like for Charizard tournament champions. And then we classify the face based on our search result, and then we annotate like using bounding box, and we denote with the character name. So this is how the system performed. So the input is also an image, and it detected the face using the function name face detect. And then it query use like query model using the keyword like Charizard tournament champion, and the maximum is like only 4 people, and then it classify the image and then tagging. So this is the visual rationale of the system. So the approach, so the input is, okay. So the input is the natural language instruction, which is our query, and so the input image. But it also have a in-context programming pairs. So using the in-context instruction program pairs and also the query, it will have a program generator here to generate Pythonic code, and then that program and also the input image will go to the interpreter, and it show our result, which is the prediction or like image editing or like object tagging and the visual rationale. So the in context instruction program pairs, it's like this. So this is a example for in context example. It's kind of like few shot. So it just instruction and then program, instruction and then program to solve that query, and instruction and then program. And then this is the query, and it asks the GPU3 to generate the program that have kind of similar form with the in context example. So for the program generator, it use GPT-3. So the GPT-3 can decompose the query to simpler task, and for each line of code, it will call a pre-trained neural model, or it's like image processing, or it can be just like some math operation. And for the program interpreter, so they wrote the program interpreter to make sure that it initialize a right way when it called the pre-trained model. And actually this interpreter made by the programmer. So the interpreter is like this. They made it by themselves. So VisPro currently it support 20 models for image editing. So these log, fade, set, select, classify, VQA, it's the name of the interpreter, the name of the function, and this function will goes to this interpreter later. So for the red block, it just called the neural model. And for the blue block here, it's some image processing, like it was using OpenCV library, or it can be just something like, for example, here comes this Python lang eval, something normal, other work rather than calling the neural model. And also it had the visual rationale. So it's HTML that summarize all the input-output step of each step. For example, here we have the task, do the globe and the pants have the same color. So it's the prediction is no. And the visual rationale will show you this is the generated program by GPT-3, and next to it, it have the output. This is the output of every single step. So later then they will show the error analysis based on this visual rationale to come up with the idea like how the error happens and how to improve the performance of the system. So they target the 4 tasks. And for the 4 tasks, which is like visual question answering, they will evaluate on the GQA benchmark. And for zero-shot reasoning image pairs, they use NLVR V2 benchmark for evaluation. So the zero-shot reasoning image pair here is so zero-shot here is not meaning that they don't give any in context example for the program. They still give it, but the neural model that it query is VQA model. And VQA, no, is it VQA? So let me check it. Yes, it used VQA model, which only trained based on like one image only, not, and it's not able to understand the image pairs, but it's still showing good performance on image pairs understanding. And for factual knowledge, object tagging, and image editing, which is quite challenging for the model that it used. And for image editing, they have 3 kind of tasks, which is like the identification, object replacement, and stylistic object highlighting. So, for example, this is object highlighting, like create a color pop on the woman in blue and the woman in red, and blur the background. So this is how it performs, or replace these 2 axes. with another actions, other actions, I think so. With other face. So it did really well. And take the woman leader of Germany, Taiwan, and New Zealand. So in this photo, there are a lot of women leader of other country also, but it detect the country, find the woman leader that corresponding to those countries. So for the evaluation, so first, they evaluate like how many number of context example that they should give in the prompt. So here we can see that the more number context example we give, the better accuracy we get. And also the another thing that they use here is measuring vote. So the measuring vote is meaning that so for the same query, for the same number of context example, we run it 5 times. And so for 5 times, it will give 5 different generated program. So if there is any program that same to exam, same to other, then they will choose that program and run it only. Instead of query 1 time and just run whatever it is. And actually using the measure voting, it shows better performance. So first for question answering, they don't run for the whole GQA data set. They only choose the subset of GQA, and so it's around like 100 question type. So they aim to evaluate the prompting strategy that I just showed the previous slide. So the measuring voting, it shows the best performance here. And also they have like curated data set. They adding, so 16 is from like they made it by themselves. And the 4 from the hallucinated cases to better coverage the failure cases. And they compare it with VILT VQA. Actually, the neural model that it the VisProc code in the visual question answering is VILT, and it showed that it's better instead of like given image and given query directly to the model, but like bringing split the step and then query the model, it shows it's perform much more better than query the model directly. For the natural language visual reasoning, so the setup is the same as before, but the model that it query here, the VisProc query here is a single image VQA model for image understanding, and it's they compare to the VOIT that chain for understanding image pairs. Even it's not like better than the neural model, but it show it's much more better than the VQA model only. For knowledge tagging, So for this task, they don't really have a data set, so they made it by themselves. They annotate like 100 tagging instruction across like 46 images. So it's around 250 instances. And the IOU threshold is 0.5. And the instruction required knowledge base. So it's impossible to just like object detector alone. So there are two versions here, the original version and the modified version. So the the original version, there are a lot of cases that it failed, or it's they detect it right, but when tagging it's slightly wrong. So they modify the instruction to have a better performance. And I will show this later, like how they modify the instruction. And it showed like very good performance. And they evaluate this by manually look at the output by themselves. So for the image editing, for this they also make the data set by themselves and also manually store the prediction by themselves. So for the value case analysis, they do the evaluation for 100 samples for each task. So there are two main reasons. The first is the incorrect logic of the program. For example, this task tag the Jonas brother who married the Indian actress. So the query here, they ask for Jonas brother, but the query should be Jonas brother who married the Indian actress rather than just Jonas brother. And the another one is either cow or horse. This is not white. So the query here is show is locate the object that horse, but it should check if the cow or the horse is white also, but there is no statement that check it in the program. So that's why it failed for this example. And the another one is the incorrect prediction from the vision model. So for this task, like either a green stop sign or a traffic light. So the prediction is yes, but actually there is no green top sign or traffic light in this image. So here locate the object that is green top stop sign. It should be none, but it detects this stop sign. So it's the incorrect prediction from the vision model. And this one also. So this is the sources of error in BizProg. So we can see that like the incorrect program and also the wrong prediction from those vision model like VQA log crop. It's make up a lot. So the improvement they made here is so more in context example will give better performance. So before they either randomly select the prompt or manually select the prompt. And also it's the same set of example for all the queries. uh, and upgrade the vision model, of course. And the tuning the instruction. Tuning the instruction is like, it's very simple approach that you just see the visual rationale and then change the query until it show the it predict right or like do the task in the right way. And it actually improved a lot. It improved like 12% for object tagging and 7% for image editing. So for example, here the task is like replace the coffee table with a glass top modern coffee table, but it failed because the query is coffee table and the category is none. But when just like modify with the words like coffee table, table merge, then when it's query the model, it generates the same statement, but the category now is table merge, and it's do it in the right way. And for example, this one, take the item that is used to make coffee. So when it localization, it used the object name item, but with the name item, it failed for this one. But when they change it a little bit, like take kitchen applicants that used to make coffee machine, then in the query, the object is kitchen appliance that makes coffee, and it's uh, uh, filtered by the log. And for future work, they so now they don't consider the image in the generated program. So they wanna also consider the image in some way, and also multi-step program generation. So for example, when it related to a website or like video, then multi-step program generation may help. So for the conclusion, it provides a visual program or complex visual task, break it into simpler steps, and query the model that like SOTA for doing that kind of simple step. And also it leverage the reasoning capability of large language model, and also it have visual rationales that are very helpful for error analysis. So do you have any questions?
So the code is available.
Yes.